The Coca-Cola Company operates with a special exemption from the U.S. government. A license granted by the Drug Enforcement Administration allows one of its key suppliers to legally import the primary ingredient of cocaine. This isn't a rumor. It's a documented fact, hidden in plain sight in the Federal Register. The company never talks about it, and it's central to the world's most famous secret formula. So what is actually happening with those coca leaves? We'll reveal the full authorized story at the very end, and it will change how you see that red can forever. Before we get there, let's go inside the factory. Every product has a secret. We're at CSEP Wakefield in Great Britain, Europe's largest soft drinks plant by volume. This single site produces millions of cans and bottles every day. To understand the sheer scale of the operation, you have to follow the journey from a single drop of water to a finished can of Coke. This is what it looks like inside. It all began on May 8, 1886. Dr. John Pemberton, a pharmacist in Atlanta, Georgia, created a syrup intended as a medicinal nerve tonic. He mixed it with carbonated water at Jacobs's Pharmacy and sold it for 5 cents a glass. The real breakthrough came when businessman Asa Candler acquired the formula and, in 1899, established a franchise system that allowed independent partners to bottle the drink. Early production was limited by hand-blown glass and unreliable seals, but a key design patent, US 48060, filed in 1915 for the iconic contour bottle, gave the brand a shape so distinctive you could recognize it in the dark or even shattered on the ground. This is how Coca-Cola was made over a century ago. Workers filling bottles one by one, sealing them with a hand press. Here's how it's made today. The modern manufacturing process begins not with flavor, but with water. Local municipal water enters the plant and is subjected to a multi-stage purification that is ruthlessly precise. First, it passes through multimedia filters to remove particles. Then, it flows through activated carbon beds, stripping out chlorine and any organic compounds that could affect the taste. The goal is to create a perfectly neutral base. But the most critical step is deaeration. Inside a Crohn's Conti flow mixer, the water is put under a vacuum, which strips out dissolved oxygen down to less than 0.02 milligrams per liter. That's a level so low it's measured in parts per billion. This prevents the final product from oxidizing, which would create off notes and ruin the taste. Next, the treated water is chilled to between 0 and 4 degrees Celsius. This cold temperature is essential for the next step. While the water is polished, the syrup is prepared in massive stainless steel tanks. Sugar or high fructose corn syrup is mixed with treated water until it hits a precise sweetness level, measured in degrees Brix. The tolerance is just a few hundredths of a degree. Then the secret ingredient arrives, the 7X flavor concentrate. It's delivered in sealed, tamper-proof containers from a central high-security facility. Bottlers never see the raw formula, they just meter it into the syrup batch. If you've made it this far, you're about to see the part they don't put in the factory tour. But first, let's look at what happens to the containers, because this is where it gets genuinely strange. Now the two streams, chilled, deaerated water and finished syrup, are blended together inside the Crohn's Conti Flow mixer carbonator. This is where the fizz happens. The cold liquid is injected with pure, beverage-grade carbon dioxide at a pressure of over 8 bar. The combination of high pressure and low temperature forces the CO2 to dissolve into the liquid, creating the signature carbonation. The level is controlled to within hundredths of a gram per liter. The finished, ice-cold, carbonated beverage is now ready for packaging. This entire global system produces 2.2 billion servings a day. 2.2 billion. That number doesn't mean anything until you realize it's enough liquid to fill 880 Olympic-sized swimming pools every single day. Think about it. Every time you've held one of these bottles, this entire global infrastructure was working just for that moment. But here's where it gets genuinely strange. While the liquid is prepared, the containers are made at an even faster rate. At a modern plant like Wakefield, small test tube-shaped PET preforms are heated and stretch blow molded into the contour bottle shape right on site. Cans arrive empty and are blasted with ionized air to remove any dust. Every single container, glass, can, or PET, then passes through a UFT inline 2 inspector. This machine uses high-speed cameras to scan for microscopic chips, scuffs, or foreign objects, inspecting up to 84,000 containers per hour. Anything with a flaw is instantly rejected. From the perspective of the line operator, these cans aren't just packaging. They are a blurred silver river. At 2,400 cans per minute, the human eye cannot see individual units. You instead watch for a change in the frequency of the sound or a slight ripple in the flow to catch a jam before it happens. From there, the perfect containers move to the filler. A Krohn's Model Fill VFSC can fill over 120,000 cans an hour. That's more than 33 cans every second. The filling is done under a counter pressure of CO2 to prevent the dissolved gas from foaming out of the cold liquid. Cans are seamed, bottles are capped, and every single one is checked again for the correct fill level using X-rays or weight checkers. The workers on this line inspect the results of thousands of units per shift. They can spot a seam defect in a can, a process called a seam teardown, with a skill that takes months to develop. No machine does that yet. The part they don't film is the constant pressure of the quality lab. Every 30 minutes, samples are pulled from the line to undergo destructive testing. If a sample fails, every can produced in the last half hour must be quarantined. Finally, a laser etches a date and batch code onto each container for traceability before they are bundled, wrapped, and sent to the warehouse by automated palletizers. This is the part of the factory that Coca-Cola doesn't show in their promotional videos. According to the company's own 2023 environmental reports, manufacturing the product is incredibly water-intensive. The system-wide water use ratio was 1.78 liters of water for every 1 liter of finished product, and 28% of that water was withdrawn from regions facing high or extremely high water stress. The company's own reports confirm this. Then there's the plastic. For the 6th year in a row, the Break Free from Plastic Global Brand Audit named the Coca-Cola Company the world's #1 plastic polluter, not by a competitor, but by a global audit of volunteers who counted the branded waste they found. How Coca-Cola is made is a story of precision, but it's also a story of consumption at a scale most people never see. The entire process hinges on one trick. They've been using it for 130 years, and most people never notice. It's called Henry's Law, and it's the reason your soda fizzes when you open it and goes flat when it gets warm. A cold liquid can hold more dissolved gas than a warm one, and a liquid under high pressure can hold more gas than one at normal pressure. The factory exploits this law perfectly. By chilling the water to near freezing and carbonating it at pressures up to 10 times normal atmosphere, they can force an immense amount of CO2 to dissolve into the drink. This is why a warm soda goes flat so quickly. The gas can no longer stay dissolved. It's also why they deaerated the water at the start. Oxygen is highly reactive. Even a few parts per billion of O2 can cause oxidative off-notes over the shelf life of the product, making it taste stale or metallic. It's an elegant engineering solution to a fundamental chemistry problem. At the beginning, we told you the DEA authorizes Coca-Cola's supplier to import coca leaves. Here's the truth. The Stepan Company, based in Maywood, New Jersey, holds a unique DEA license to import coca leaves from Peru and Bolivia. Inside their secure facility, they perform a chemical extraction to remove the cocaine alkaloid. That alkaloid is sold for medicinal purposes. What's left behind, the decocainized coca leaf extract, is what Coca-Cola buys. This extract is a key component of the natural flavors listed on the ingredient panel. It is part of the legendary 7X formula. So when the company says the recipe is secret, this is part of what they are protecting. Not an illegal substance, but a legally controlled, globally unique supply chain for a single flavor ingredient. A process hidden in plain sight, protected by federal law. Before we wrap, here's something most people don't know about Diet Coke. You've seen the warning. Phenylketonuria contains phenylalanine. This isn't a suggestion, it's a mandatory legal warning under federal regulation, 21 CFR 172.804. The artificial sweetener used, aspartame, metabolizes in the body into several compounds, one of which is phenylalanine. For the vast majority of people, this is harmless. But for individuals with the rare genetic disorder phenylketonuria, or PKU, this amino acid is toxic and can cause severe health issues. The same factories, the same machines, but one different ingredient requires a warning dictated by law. Next time you open a can of Coke and hear that signature hiss, you'll know it's not just soda. It's the sound of chilled water, high-pressure carbonation, and a century of chemistry escaping the can. You'll know that the water was polished, the sweetness measured to 1/100th of a degree, and the can itself was inspected by a machine faster than your eye can see. You are now one of the few people who understands the entire journey. So next time you hold that iconic bottle, you'll know that its natural flavors come from a supply chain unlike any other on Earth. Thousands of workers, billions of cans, and over a century of engineering. All so you never have to think about it. Now, we want to hear from you. Here's a debate. Should companies with secret formulas be required to disclose all their ingredients for public safety? Let us know your thoughts below. Also, tell us which country you're watching from. And finally, what product should we go inside next? The top voted comment becomes a future video. Next week, we're going inside the factory that makes Tabasco sauce. Subscribe so you don't miss it. 2 more factories are waiting for you right now.